The situation described involves a potentially dangerous and improper installation of an electric hot water heater. Connecting a 2 kV amps heater to a 15 amps outlet using an extension cord is a significant safety hazard and a violation of electrical codes. The primary concern is overloading the circuit. A 2 kV amps heater, which is 2000 volt amps, operating on a standard 120 volt circuit would draw approximately 16.67 amps. This calculation comes from the formula amps equals volt amps divided by volts. That is 2000 divided by 120 equals 16.67. Connecting this to a 15 amps outlet exceeds the circuit's capacity. An overloaded circuit can cause the breaker to trip, which is a safety mechanism designed to prevent overheating. However, if the breaker fails or is improperly sized, the excessive current can generate significant heat in the wiring. This heat can melt the insulation on the wires, creating a risk of electrical shock and potentially causing a fire. The use of a spliced extension cord further exacerbates the safety concerns. Extension cords are typically not designed for permanent installations or for handling the continuous high current draw of a water heater. Splicing the cord introduces additional points of resistance, which can also generate heat and increase the risk of fire. Furthermore, running a cord through a wall creates a penetration that is not designed for electrical wiring and could damage the cord's insulation over time due to friction or abrasion. The National Electrical Code, NEC, specifically addresses the insulation requirements for electrical appliances, including water heaters. The NEC provides guidelines for wire gauge, circuit breaker size, and proper wiring methods to ensure safety and prevent electrical hazards. Firstly, the water heater should be connected to a dedicated circuit of the appropriate amperage. For a 2 kV amps heater operating at 120 volts, a 20 amp circuit would typically be required. This dedicated circuit should run directly from the electrical panel to the water heater without any other appliances or loads connected to it. Secondly, the wire gauge must be sized appropriately for the circuit amperage and the distance of the run. The NEC has tables, such as Table 310.15b16, that specify the allowable ampacities of different wire gauges based on insulation type and installation conditions. Using undersized wire can lead to overheating and voltage drop, which can damage the water heater and increase the risk of fire. Thirdly, the connection between the circuit wiring and the water heater should be made using approved wiring methods and connectors. This typically involves using conduit, such as electrical metallic tubing or rigid metal conduit, to protect the wiring and prevent physical damage. The connection to the water heater should be made inside a junction box using wire connectors that are rated for the wire gauge and the environment. The use of an extension cord for permanent appliance installation is a clear violation of the NEC. Fourthly, grounding is a critical safety measure that helps to prevent electrical shock. The water heater should be properly grounded to the electrical system to provide a path for fault current in the event of an electrical fault. This grounding connection should be made using a grounding conductor that is sized appropriately for the circuit amperage. The grounding conductor should be connected to the water heater's grounding terminal and to the grounding busbar in the electrical panel. Fifthly, overcurrent protection is essential to protect the circuit and the water heater from damage due to overloads or short circuits. The circuit breaker in the electrical panel should be sized appropriately for the circuit amperage and the wire gauge. The circuit breaker should be a listed and labeled device that is designed to protect the circuit from overcurrent conditions. The installation should be inspected by a qualified electrician to ensure that it complies with all applicable electrical codes and safety standards. A qualified electrician has the knowledge and experience to identify potential hazards and to ensure that the installation is safe and reliable. The electrician can perform a load calculation to determine the correct circuit size and wire gauge, and they can verify that the grounding and bonding are properly installed. In the specific situation described, the immediate course of action should be to disconnect the water heater from the 15 amps outlet and remove the spliced extension cord. The next step is to install a dedicated 20 amp circuit from the electrical panel to the water heater. This circuit should be wired with the appropriate gauge wire, such as 12 American wire gauge, or copper wire, and protected by a 20 amp circuit breaker. The wiring should be run in conduit to protect it from physical damage, and the connection to the water heater should be made inside a junction box using approved wire connectors. The water heater should be properly grounded to the electrical system. After the installation is complete, a qualified electrician should inspect the work to ensure that it complies with all applicable electrical codes and safety standards. The electrician can also perform a voltage test to verify that the water heater is receiving the correct voltage. In addition to the electrical considerations, there are also plumbing considerations for installing a hot water heater. The water heater should be installed in a location that is accessible for maintenance and repair. The water heater should be installed on a level surface and should be secured to prevent it from tipping over. The water heater should be connected to the water supply lines using approved plumbing fittings and materials. A temperature and pressure relief valve should be installed on the water heater to protect it from overpressure and overheating. The discharge pipe from the temperature and pressure relief valve should be routed to a safe location where it will not cause damage or injury. The installation of a hot water heater requires a thorough understanding of electrical and plumbing codes and safety practices. It is essential to hire a qualified electrician and plumber to ensure that the installation is done correctly and safely. Attempting to install a hot water heater without the proper knowledge and experience can be dangerous and can lead to serious injury or property damage. It is also important to note that electrical codes vary from jurisdiction to jurisdiction. It is essential to consult with the local building department or a qualified electrician to determine the specific electrical codes that apply to the installation. Adhering to these codes helps to ensure that the installation is safe and compliant with all applicable regulations. By following proper installation practices and adhering to electrical codes, it is possible to safely and reliably install an electric hot water heater. This provides a source of hot water for domestic use. Improper installations pose significant risks, including electrical shock and fire, and should be avoided at all costs.